On this 7th day, we're going to cover Boolean logic as it relates to programming. And I'm going to introduce the if statement. So stand by, because this video is about to start. This is the Savage Scientist Ed right here, and I'm writing code in a police code. What's up, folks? You already know who this is. This is the Savage Scientist Ed, and this is our 7th day of learning C++ in 31 days. And in today's video, we're going to cover the basic logic for programming so you can get started with writing meaningful programs in C++. So I think it's time for you to hit that like button, subscribe to my channel, and share this video so other folks who want to learn C++ could come over here and learn this stuff. With that being said, it's time for us to continue our journey. And here's the index for this video. Jump to whatever topic you want to see or follow the video in the order you see it presented right here. So, what is Boolean? Boolean is a value that's either true or false. That's it. And true or false just means it has two states. And keep in mind, we're talking about C++, but this could be applied in any programming language. Now it's time for us to take a look at our Boolean operators or logical operators, whatever name you want to call them. I interchange them both. So let's take a look at the priority. We're going to rank these from high priority to low priority, starting with the negation operator, and then we move to our comparison operators. We have our greater than, and we have our greater than equals. That's exactly how it's written here, greater than and equals. In the math class, you might see a combined sign with a line under the bottom, but we're looking at the C++ way it's done. So since there's no line with a line up under it, like in math, we got to write it like this. So same thing for our less than, equals. And then we're looking at our equivalency operators. That is the two equal signs. That means that we're going to be comparing the left to the right. If they are the same value, then we're going to say that's true. And if it's not, we're going to say that's false. And now it's time for us to flip the script and look at the not equals. And for our not equals expression to be true, that means that the actual expression has to be false. So 5 is not equal to 7. That's actually true because they're not equal. So that's why it became true. And in our not situation, if you set the two values equal, then the result is going to be false. So last, we're going to take a look at our logical comparator operators. This is our logical and, meaning that we're going to have a condition on the left side and a condition on the right side. And the left and the right side has to be true for the entire expression to be true. And we're going to look at our logical OR operator. What that means is that we could have an expression on the left side, or we could have an expression on the right side. Only one of those has to be true for the expression to be true. Both of them could be true, but you can't have both of them false. If both of them false, then the entire expression is false. So normally in a logic class, you'll see this stuff in the truth table. But to keep this video short and simple, we're going to just move on to the code. So this is what our little ugly ass program is about to look like. We about to create the poor man's calculator here. And it's going to have additional functionality based on what operation you're going to choose. So we're going to implement logic so you could be able to enter two numbers and decide whether you want to add, subtract, multiply, or divide those numbers. So let's start creating this shit. So we start in dev C++. Let me get it in place here. All right, so now let's open up our last program, our last project, and here it is. And we're going to start off by getting rid of all of the assignment values, and we're going to change our x and y to ints. So like I said here, we're going to be saying we're going to do our arithmetic operations on the values x and y. So we're going to continue to use the same name, poor man's calculator. And let me space that correctly. Let's get that in the right spot. So I'm also going to force this onto its own line. So that's in this part. And put an ENDL statement right here. And we're going to get rid of this new line because we put this on its own line like this. So we have poor man's calculator, and now we're going to say enter the first number, and this is where, and right here we're going to actually get the first number. So now we're going to ask for the second number, and we're going to get the second number with this line. So we're going to also create a value called result. Well, we're going to use our results. Let's move this up to our declaration section where we declaring our values, our variables. So we're gonna have another int called results, and we're gonna name this one remainder with a lowercase r, and I'm gonna move that up to the top. And I'm gonna get rid of the mathematical part here where we calculating the remainder. And I'm gonna get rid of all this stuff up here too. This isn't necessary. And now we have cleaner code. We have our X, Y, remainder, and result. And what else we're gonna need? Program. So let's start here by calculating our values here. So we're gonna need one to hold our choice. This is our declaration section, and this is the actual programming logic starting here on line 12. So the first thing we're gonna do is ask for the choice. What type of calculation? To perform. All right here. And we're gonna just list out our full calculations here. And I'm gonna say something like enter 1 for addition, and we're gonna continue to repeat this 4 times because we're gonna be looking at 4 operations. And let's clean this up. All right, so we're gonna do 2 for subtraction, three for multiplication, and 4 for division and modulus. So those gonna be our 4. Those gonna be the 4 options you're gonna have with this calculator. So now let's get user input CIN statement in here for the choice. So now we're about to look at the if statements part. So if choice has the same value as 1, that means we're about to do our addition. So I'm gonna put a comment here just so I can know we're doing addition. And now we're about to put the logic in right here. So what we want to do, we just want to print something out to the screen saying this is the results. COUT, out. And we're going to say the result of, now we're going to say X and we're about to print our plus sign right here, plus. And we actually printing the value of X and Y, not just X and Y. And you can tell that because you see how there's the X's outside the parentheses and the Y outside the parentheses. That's so we know we printing real values here and Y. So, and we're putting the space before and after our values. So the result of X and Y equals, now this is where we're going to compute x plus y. And there it is. And we're going to end our statement right there. This is all we're doing. So when our choice is equal 1, so that means that you entered 1 right here, we're going to have this results. And we're going to copy this whole thing and do the same for the rest of the operations. So let's copy and paste it here. So if choice is 2, we're going to do subtraction, right? And we're going to change this to say subtraction. And the only thing we're doing is changing this to subtraction. And we're going to do a subtraction sign right here in our code so it could compute x minus y. And now we're about to do the same for the third step of multiplication. Look at that spelling. I could have put an X there, but that star sign seems to work better because that's exactly what we're doing right here. You see, it's star, not X. We're not doing that. We're doing star because we already have an X there anyway. And let's see, we have our choices of 1, 2, and 3 for multiplication. And we have one more to do. If choice is 4. Now we're about to do our division and modulus. And let's add, we have to add one more part to it. We could just say mod of x modulus y. So there we have it. So now it's time for us to check to make sure this is working. So let's compile it. And there it is. So let's test it out. Let's see what happens if we type in 76 and 3. Let's add them together first. 76 plus 3 is 79. So I want to test everything without having to close the program. So now let's run this in the console. Let's see, project 1. 42 and 354. What we want to do, subtract. So subtraction is 2. There go our big negative number. Let's try this again. This time with 7. We're going to be multiplying. So 7 times 10. Multiplication number 3 is 70. And now let's do this one more time for dividing. So we're going to say 876 divided by 65. Hit our number 4 here. So there it is. 876 divided by 65 is 13 with a remainder of 31. So there we go. So now it's time for us to play with this, and let's break this program. So let's run it again. Enter our first number. There's our second number. So let's enter 9. And when you enter 9, you see how we not getting anything. So what I'm about to do now is restrict the program to make it so no matter what value you type, it's gonna give you an operation. So when we hit 9, we're gonna look at the remainder of 9, and it's gonna give us probably let's see, the modulus of 9 and 4 would be 1, because 9 divides 4 2 times, so that's 8, and 8 will give us a modulus of 1. let's make sure. Let's use our calculator. It is a calculator, right? So let's see what the modulus of 8 and 9 is. I mean 4 and 9. So let's run our program again. So let's type in the first number is 9, second number 4, and we about to run number 4. There it is. So that's it. 9 divided by 4 is 2 with a remainder of 1. So there it is. Damn calculator really coming in handy right now, right? You made a calculator. Be proud of yourself. So now it's time for us to restrict the values. So let's go back to our choice right here. And we're going to set choice to modulus. Choice equals choice modulus 4. And that's going to restrict the values to only 1, 2, 3, and 4. But really we're going to have 1, 2, 3, 0, and 4. So when it's 0, we have to deal with it, because watch what's going to happen whenever we run this thing with 0. Let's rerun our program. Open it up down here in the console. So our first number is 84. We're not really worried about that. So what's going to happen when it's 0? So let's type in 64, because like we know, 64 divides 64 8 times with 0 as a remainder. See, we got that again. We are about to make it so when we hit 64, it's going to give us the fourth choice and give us the remainder, division, and modulus. D-I-V-I-S-I. I spelled it right. All right. I want to make sure here. So the only thing we're going to do is use our logical OR sign. Check it out. We're using OR. So we're saying choice is either 4 or choice is 0. And we're computing our choices to be restricted to only those values. So really right here, we're saying choice is going to be 1, 2, 3, 4, or 0. So really, we don't even need this part. But let's look at it anyway. Since it's here, we're going to leave it here. So let's run our code again. We're going to put it right here so you can see. Enter the first number, 432. And let's type in 4. There it is. So let's run it in our console this time so we can keep it on the screen. I'm going to try 423, 21, and we are about to use 64. And there it is. So let's look at what's the remainder of 64. 64 and 4. And 4. There it is. See that? When it's 0, there it is. That's our mod right there. So now let's look at what would happen if we take this 4 off right here. So if our choice is 0. So what's going to happen when it's 4? Let's see. But if you listen to what I just said, then you already know what's going to happen. So let's see here. So let's take 448. You know, I should have just did the numbers that we're working on. So let's do 4. Put our 4 in here. See, there it is. And that's the same thing. Is we don't even need choice is 4, because 4 modulus 4 is 0 anyway. 4 divided by 4 divides 4 one time with a remainder of 0. So that's it. So we're going to work on some more of this. We're going to make it so this program, which doesn't even have a return value. So let's put our return value here to make it so it's a complete program. So y'all should have caught that. So now our program is complete with a return value. So next time when you join us in this C++ journey, this C++ mission, we're about to talk about what is next. Okay, so we just got done talking about the topic of day 7, Boolean and logic for programming. We're about to recap everything on day 8 tomorrow. And then that's whenever we're going to On day 9, we're going to continue with our loops. So we got a lot more stuff to cover. We got all this stuff to cover. So this is the Savage Scientist Ed, governor of the state of Swamplands, and you just watched our 7th day of programming. So till I make my next video, we're going to do this on the big screen. So till I make my next video, peace out.